The way industry handles safety issues is they rely on standards. In every industry except cars, there are a set of safety standards that have been published and the industry follows. Either the regulators make them follow it or the customers make them follow it. So if you get on an airplane or you get on a train or you rely on a power infrastructure or you have a petrochemical plant somewhere nearby, in all those cases, the reason you generally trust them and believe that they'll be safe is because there are industry safety standards they follow. The car industry is dramatically different. The car industry is not required to follow their own safety standards, and in many cases they do not. Nonetheless, the standards are there. So let's go down the automotive standards. There's ISO 26262 functional safety. That covers runtime faults and design defects. This standard has been around for more than a decade, and it covers software and computer-based system safety for conventional vehicles, but is still applicable to autonomous vehicles. It assumes, however, that you know all the requirements. You have to have a complete set of requirements for the standard to really do its job. That works for things like brakes and electronic throttle control, but it's not as much as you need for something based on machine learning. For that, there's another standard, ISO 21448, SOTF, Safety of the Intended Function. And the idea here is it helps you identify and mitigate unknowns. The standard explains how you search for unknown unknowns, and when you find them, you pull them into the requirements, and you mitigate the risk, and you continue until you run out of unknowns. That standard is great as far as it goes. It gives you methodology, but it still helps to prime the pump with a list of unknowns so that you don't have to discover every single one for yourself the hard way by driving hundreds of millions of miles. You need, did you think of that lists? Here's an example in downtown Pittsburgh. A bus was driving along and all of a sudden the ground opened up and swallowed up the back end of the bus. Fortunately, there was a human driver who had the presence of mind to say, gee, this isn't right. I think I should let my passengers out before something worse happens. And eventually a giant crane came and pulled it out of the hole. But these types of things happen. There's an essentially infinite list of things that can happen. You will not have seen all of them during your testing and training. On the other hand, if you had a list that said, think about sinkholes, you don't need to wait for the sinkhole to happen to think about it. So to get safety, you need more than just applying these two standards. You need a technically substantive safety argument. I'll get to what that means in a moment. You need evidence of coverage initially at the time you deploy, and feedback from surprises. You want to have thought of most of the surprises you can, even if they haven't happened to you yet, and make sure you have them covered. You need to then realize and have the humility to know that you will never think of all the surprises. So you need a very strong continuous improvement process to notice when things go wrong in the real world, even if it does not involve a crash, and learn from them so you can prevent bad things based on initial symptoms instead of waiting for the bad outcome to fix a problem. And you need a way to organize everything so that all these pieces come together to ensure safety. The way to organize them is called a safety case.